All right, for our final two lessons, or two short sections here in Unit 4, we're going to focus on right triangles and then overlapping triangles. Now, a little bit of review, we need to understand what right triangles are and a little bit of the anatomy of right triangles. I'm going to do one kind of quick example with that, and then we'll deal with more examples and exercises in class. And then on the second part, dealing with overlapping triangles, we're going to try to understand when we have a kind of a shared segment or a shared angle between two kind of overlapping triangles and use the reflexive property to say, hey, this is the same angle, these are congruent to each other, and be able to think through that and then work through that in our geometric proof. So first, let's focus on right triangles, and there is a magical shortcut that we will get to use here involving right triangles, but first let's try to understand a little bit of the definition of a right triangle. So again, a right triangle is a triangle that has a right angle. A right triangle will have sides that are perpendicular to each other. If those segments are perpendicular, then that means that that's a right angle. If that's a right angle, it means that those angles are congruent to each other. Or what we're going to say here is if we have right angles in triangles, we're going to call these right triangles by the definition of right triangles. All right? So we're not going to use perpendicular segments make right angles and right angles are congruent. Instead, we're going to say perpendicular segments make right angles, which means that we have right triangles. The hypotenuse of your right triangle is the side that's opposite from the right angle. It's the longest side. Remember when you would do a squared plus b squared makes c squared? C was always the hypotenuse, all right? The legs are the two sides that include the right angle, all right? The sides that are not the hypotenuse. And so hopefully that anatomy lesson for a right triangle is not too fresh, or is not too new as far as that goes. Hopefully, apologize for that bell. Hopefully you already had a grasp on that vocabulary, but there's hopefully a useful reminder. The hypotenuse leg theorem is basically I mentioned before that we can't use angle side-side congruence. It's not a safe shortcut because there's a little bit of ambiguity there. But what we know with right triangles is that if I know the lengths of two sides, then I can use the Pythagorean theorem to find the length of the third side. And you've already done a lot of that practice in algebra and pre-algebra. And so here, the way that we understand that is if we're dealing with right triangles, all right, then we know if I have a pair of hypotenuses congruent and a pair of legs congruent, then I know that the third pair of legs has to also be, or the other pair of legs has to also be congruent, and therefore the triangles are congruent. So here, if the hypotenuse and one leg of a right triangle are congruent to the hypotenuse and a leg of another right triangle, then those triangles are congruent. So this is kind of like saying angle side side, even though we're not supposed to say that. We're going to say, not that these angles are congruent, but we're going to say these are right triangles. These are right triangles with the hypotenuse is congruent and these legs congruent, therefore the triangles are congruent. All right, and that's going to be our structure. Here, we are shown in this proof, draw that picture to the best of your ability, mark this given information as needed. Segment AD is the perpendicular bisector of segment CE. There's two things happening there. One, it's intersecting to make right angles. So the angles around B are going to be right angles, which means that these triangles are right triangles. Since these triangles are right triangles, I can say if the hypotenuses and a pair of legs are congruent, then those triangles are congruent. So I'm going to use the hypotenuse leg theorem here, stating that these are congruent because given, these are congruent by the definition of bisect. All right? So let's write out that proof. If you want to write out that proof before I do it, you should do that just for the practice, listening to what I said, and then try to write out those steps. Otherwise, here they go. Segment AD is the perpendicular bisector of segment CE. That's given information. Focusing just on the perpendicular part, we're going to say that angles CBD and EBA are right angles by the definition of perpendicular, which means that these two triangles are right triangles. Okay? We're going to state, given perpendicular segments, we make right angles. Traditionally, we would say, ooh, then those right angles are congruent because all right angles are congruent. We're not using angle side side here. We're not using a shortcut. We're using hypotenuse leg shortcut. And so instead, we're going to say, hey, these are right triangles because the hypotenuse leg only works in right triangles. We have to say that these are right triangles. Now, segment CD is congruent to segment EA. That's given information. And segment CB is congruent to segment EB by the definition of bisect. All right, we bisected segment CE. I know that that's marked in the picture. I want to be clear about what's given as a statement. using the definition of bisect versus what's given in the picture. I apologize that it's already marked for you. And therefore, the triangles are congruent using the hypotenuse leg shortcut. Let me know if you have any questions or concerns about that proof. All right? You can send me an email or comment privately on Google Classroom. That is it for lesson 4.5. We will do more exercises and examples with hypotenuse leg. I'll have you do some, I'll do some as well, and take questions in class as needed. In lesson 6, we're going to deal with overlapping triangles. And this part gets a little bit tricky visually speaking. I think that at this stage, the hypotenuse leg, we can do one example and that's good enough. On this part, there's a little bit of visualization in play. When we have overlapping triangles, parts that are kind of overlapping each other, we should see that there's maybe a shared side or a shared angle, and then therefore those parts are reflexively congruent. So in this picture, keep that off for just a second. Look at this figure, this strange quadrilateral. We've got G, D, whatever that point is, E. All right, we've got this strange quadrilateral, and then there's a segment that connects through, and you can tell that there's a triangle GHE and a triangle GFD. If you can, do your best to separate those two triangles. So here we have GDF, which is this triangle right here. And then we have triangle GHE, which is this triangle here. Can you see that they both share this vertex, this angle at G? Hopefully, if you can see that, and if you can see this common angle or this shared angle or this overlapped angle, you can notice that these angles are the same angle. I can call it angle G, but in this triangle, angle G is angle DGF. In this triangle, angle G is EGH. It's the same angle though. So this angle is congruent to that angle, all right, by the reflexive property of congruence. And so we'll use that in our geometric proof. Now, I know that this part of this side is in this triangle, and it's also part of this side in that triangle, but I'm not going to say that GF is congruent to GF. That's not useful because GF is a side here, but it's not a side in the second triangle. We want to be aware of things that do overlap but are not necessarily helpful in proving the triangle's congruent, all right? Here, this is the same angle, so that's useful. So let's take a look at this example here. Maybe a confusing picture. You'll notice that this point is not labeled. That's intentional because we're not going to use that point. All right? So looking at this picture, we're told that these angles are congruent and those angles are congruent. So that basically means the big angle at W is congruent to the big angle at X. All right? That's ZWX, which is right here, is congruent to YXW. That's this big angle there. That's this second statement. We also know that these little angles in here at X and at W are also congruent. So that's ZXW is right here. That's this little guy. And then YWX is marked congruent. That's this little guy. What's helpful to note is one that's given as statements, but it's also drawn and labeled in the pictures. What's helpful to recognize is that we have this shared side in both triangles. WX and XW are featured in those triangles. All right, so we know that we have a reflexive segment congruent to itself. What is very difficult is visualizing the two triangles that are congruent, right? And so this is going to be a little bit fun. Here's what we're going to do. We are going to show that this is ZWX, and we're going to show that this is YXW. We have WX and WX, it's the same segment. ZWX is this big angle here. YXW is that big angle there. And then there's these little angles here, ZXW, which is right there, and YWX, which is right there. Hopefully you can tell that we have angle-side angle congruence. What I would like for you to do here is, we're not going to do that quite yet, we're just going to prove that triangle ZWX is congruent to triangle YXW. I want for you to do this proof. Take that information, draw those separate pictures, mark your pictures appropriately, label them as well, and then do your proof that those triangles are congruent using angle-side angle. We'll talk about this last piece in a minute. All right. After we go over that one in class, be sure to see me with questions or ask them during class while I work through that example. And I'll tell you about that final piece, which we're actually going to use in this proof right here. All right, so here we should see that we've got a pair of triangles, and a pair of triangles. All right, there's 3 pairs of triangles in this picture. We're going to focus on 2 pairs of triangles. I'm going to focus on the big pair, which is QPS. Maybe I should draw that a little more like so. QPS and QRS. Oh, bad drawing. There we go. It's a little bit better. We know that these are congruent and these angles are congruent. That's given information. I also know that we have the reflexive property of congruence. Now what's helpful here is that I can see that these big triangles are congruent to each other using side angle side. Let's go through that first. I'm going to prove that these triangles are congruent in a little bit. That's these little guys right here, QPT and QRT. But first I'm going to show that these big triangles are congruent. When I do that proof, it's only 4 steps to show that these 2 big triangles are congruent. Hopefully you can see the parts and pieces that make the pair of sides, the pair of angles, and the reflexive side, SQ congruent to SQ. But what we're going to do is we're going to use these overlapping triangles to recognize that we've got congruent triangles already. Now, you might not remember this from a few lessons ago because I said write it down, but we're going to not use it yet. This is the phrase that says corresponding parts of congruent triangles are congruent. All right? Corresponding parts of congruent triangles are congruent. Meaning that if these triangles are congruent, then we can apply the definition of congruent triangles to say, hey, guess what? This segment is congruent to that segment. All right? If those triangles are congruent, then all of their corresponding angles are congruent, all of their corresponding sides are congruent. Furthermore, the angles at Q are also congruent to each other by the definition of congruent triangles, or by CPCTC. Once I've shown that these triangles are congruent using side angle side, I know that all of their corresponding parts are congruent. Now I'm going to care about these 2 pieces in particular because those are shared angles in these 2 triangles. All right? Now, in this pair, QPT and QRT, I've got a pair of sides, a pair of angles, and then this reflexive segment QT congruent to itself. So what I did here, and I want you to realize the size of the work that we did. Easy proof. I want you to recognize that. Easy proof. PSQ congruent to RSQ. Easy work there. Hopefully, pair of sides, pair of angles, big reflexive side. Had to visualize that maybe a little bit different. But once I've shown you that they are congruent, I can use their corresponding parts to now do another pair of side angle side. Watch this, please. Segment PQ is congruent to segment RQ by CPCTC, or if you just want to say it by the definition of congruent triangles. That's totally cool with me. We have angle PQT is congruent to angle RQT by CPCTC, or the definition of congruent triangles. And QT is congruent to itself by the reflexive POC. Which means that this pair of triangles, QPT, QRT, are congruent by a pair of sides, a pair of angles, a pair of sides. So what we've done here, and what I want for you to recognize, is that we have taken one pair of congruent triangles that share overlapping parts with another pair of congruent triangles, and we've used those overlapping parts, or those shared pieces, to prove another pair of triangles congruent. This is pretty tough work. The way that you would finish the previous example is by saying, now that you've proven triangle ZWX congruent to triangle YXW, now we know that their corresponding parts are congruent. And so we can use CPCTC, or the definition of congruent triangles, to round out that example on the last page. Hopefully, in this conversation, you are now able to prove triangles congruent when there are overlapping congruent parts. Let me know if you have any questions, and I will see you after Thanksgiving.